No. Temperature in the atmosphere. C, last group.
Something related to elevation.
Okay. Okay.
Chemicals induced to it that shouldn't be in there.
Okay, chemical contamination. Okay. A, what was your worst idea?
Well, you said that the mix is all executive side of the inadequate mixing.
Inadequate mixing? Oh, that's a pretty good idea. That's not the worst. No one urinated in your concrete or anything. That's a good one. That's a good idea.
I guess the local aggregate, not the right material, because you're not taking any local aggregates because they send.
A mix up in materials. That was your least favorite one. Okay. Yeah, because the laboratory would have checked that. What's your?
Truck not to be out properly. So
Those are all good ones, though. Those are all good ones too. Okay. Yeah. Huh?
Sabotage.
Yeah. That happens. That happens. Where's the lights? What's the light? Which light? Concrete. This concrete that we made was drying up. We don't really think it was contamination because we actually saw them make a truck. They duplicated what they could make in front of your eyes, and they more or less duplicated the same phenomena, that it was drying up. Where'd the water go? We don't think it's a cement-water reaction. We think there's something else that's going on here. You guys had all talked about temperature and elevation and atmosphere and humidity. You're there, you're skirting around the issues, but probably you just don't know the materials well enough, and that's why we're doing this today, so you will know the materials well enough. But you're all touching on the issues right here. When you make concrete, you guys have maybe done this camping at a fireplace. Do you ever get rocks and soak them in water in the fireplace and then throw them in the fireplace and watch them explode? Poof! Rock will come flying out there. What happens is that rock you threw in a bucket of water, it sucked up water. And then when you threw it into the fire, all that water changed into steam very quickly and exploded that rock, like popcorn. It exploded that rock. Well, all of these rocks in concrete hold water. All of these rocks here and all that sand holds water. They call it absorbed water. Most rock will hold, in this case was probably about 2% of its weight in water. And in other words, if you dry in an oven, you dry out rocks, you put them in a bucket of water, you let them soak overnight, you dry them back off so that they're surface dry, you weigh them, they're going to be 2% heavier than they were the day before. In a case of sand, Wafeek, what, 12%, 14%? Sand can actually hold up a lot of water, not on the surface. This is inside the material, like a sponge. It's actually sucking up water. It's the reason why the rock blows up when you throw it in the fire, because all that steam's trying to escape very quickly out of that rock, so it pops. The giveaway in this particular case was when this guy, you could see the front end loader here picking up his aggregate. He picked up his aggregate and he dumped it into that bucket, and a cloud of dust came off the aggregate that completely covered the whole backside of his tow motor, of his front end loader. Dust. That means the aggregate, if it's dusty, the aggregate can't be wet, right? Because if the aggregate's wet, it's not going to be dusty. And you guys had said, you know, humidity, temperature, elevation, atmosphere, all these things are conducive in that part of California. I mean, you're all on the issue. They're all conducive to drying. That's why we're capturing the water out there. There is no water. This is California. That's why we dam up all the rivers. To capture all the water. So their aggregates were, they call it saturated surface dry. If you put those aggregates and let them suck up their full absorption of water and then take them out and dry the sheen off the aggregate, just let it lay out there so that the sheen evaporates, that's considered saturated aggregate surface dry. The aggregate is fully saturated. So the aggregate doesn't know whether it's getting water from rain or purposefully putting water on, or whether it's sucking the water out of the concrete. It's physics. It's going to take water. It needs to absorb so much water. So when they were making concrete here with this bone dry aggregate, because it's dusting all over the place, that was the tip-off, that they were working with aggregate that was below SSD. When they made the concrete, the aggregate literally sucked the water out of the concrete. In that 10 to 15 minutes, 25 minutes that it took to drive that 100 yards, the aggregate sucked up the water so much that there was no water left in the concrete. It was all inside the aggregate, or trying to get inside the aggregate. You with me on that? Does that make sense? And that was actually the root cause, that the coarse aggregate and the fine aggregate, the coarse aggregate had about a 1.8% absorption. On both, we figured the ash was there also, or the sand was there also, the fine aggregate. Combined, those materials were 2,800 pounds worth of material, and 1.8% absorption told us there were, roughly, we were lacking 42 pounds of water, which is roughly 8.3 gallons of water, which in a yard of concrete, rule of thumb, 1 gallon equals 1 inch of slump. So if we were making a 6-inch slump concrete at the batch plant and we lost all this absorption, we went from a 6-inch down to a 1-inch slump, and that's why they couldn't get it out of the truck. The aggregate sucked up the water out of the concrete and made it so they couldn't do it. They couldn't place it. They were able to place it then, pump it into place. The red fugitive dye on the surface is actually a curing compound to seal in the water so that it fully hydrates. And that was their corrective action, was they batched all the aggregates first in those trucks and added the water to those aggregates for 15 minutes. Let them mix inside the truck, let all the rock suck up, or at least try to stabilize its initial draw on the moisture, and then made concrete on top of it. And they were able to make the 10,000 PSI concrete and pump it and do all the good stuff that they had to do on site. Questions? Questions?
Were they allowed to add water on the site?
In most cases, well, no. In most cases, that's the first thing on a construction site that is not allowed, is adding water to concrete. It's what everybody wants to do because it's the easiest thing to do, is to add more water to it. You add more water to it, and you change that water-cement ratio when you do that, and that's the #1 thing that affects strength and performance, is changing by adding more water to it. So you're making it weaker the more water you add. So no, they didn't add water. They knew it was supposed to work. They had the mix designs, and they knew it worked in the laboratory. Now they just had to duplicate it in the field. And it's something, the whole point here, though, is that even though we're talking about high-performance concrete and real exotic and in the faraway places, it's real basic fundamentals. It's physics. The rock has to satisfy its water demand. It all starts there. Unless you can't make concrete unless the aggregate is at SSD. And I've seen it in Bloomington. I've seen it in Indianapolis. I've seen it in Troy, Illinois. I'm thinking of areas around here where people are trying to make concrete with aggregates that's below SSD. They wonder why they can't control the properties of the concrete. In the meantime, the concrete is constantly changing because the aggregate's sucking up the water. So, rule #1, real fundamental, the aggregates have to be fully satisfied with their water demand in order to make concrete. If they're below SSD, you'll see this stuff happening, and when stuff like this happens on a job site, it's real easy to sit in a classroom and peacefully discuss what's going on a job site. There's a little bit more tension that happens, and you're trying to think through these things, and sometimes walk away. Walk away and go think. Walk away and go watch them batch the concrete. Go watch them do it again. See this cloud of dust come up over top of the front end loader and go, the light bulb goes off over your head. It's dry. It's bone dry. That's the answer. You go home or go for a hike. On deck placements, something you find with high performance concretes are that they're very low in bleed water.